This is another differential equation question. Notice they give you a differential equation. Y is the solution, and they give us an initial point. They want us to find the limit and show the work that supports your answer. So typically if it's a quotient, remember the first thing we want to do is check if we have to use L'Hopital's rule. But for L'Hopital's rule, you do want to do the top and the bottom separately to show the work. So if I do this, this is really the same as the limit x goes to 0 of f of 0 plus 1. And this is going to be negative 1 plus 1, which is 0. And then this one, the bottom, limit as sine of 0 is really 0. So I do get 0 over 0, so I'm going to apply L'Hopital's rule. So L'Hopital's rule says that I take the derivative of the top separately, derivative of the bottom separately, and let's go ahead and plug in the 0 now. So if I do that, I have cosine of 0 here. I know the bottom is 1. F prime of 0 is going to be the slope. Notice it's given at x equals 0 and y equals negative 1. So if I plug that in, notice you get negative 1 squared times 2. So that'll give me positive 2. So this limit is actually 2. Part B is asking you to use Euler's method. And we're going to start at x equals 0, 2 steps to get to 1/2. So that means x is going to change, delta x is 1/4. And this is my starting point. I do need the slope. The slope is given up at the top. It's y squared 2x plus 2. So if I plug in 0, 1, this gives me 2. So the slope is 2. So my first equation for Euler's method is going to be y plus 1 equals slope. And then remember that x minus x1 is your delta x. And then we have to find the y value. So it's going to be negative 1 plus 1/2. I moved that 1 over, so it's really negative 1/2. So the next point that I'm going to use is my x coordinate is going to go up by 1/2. And then this is my new y coordinate. I'm sorry, my x coordinate is going by 1/4. That was my delta x. And here's my new y. I need to find the slope again. So using the same equation that was given, if I plug in 1/4 and negative 1/2, 2 times 1/4 plus 2. And if you do the arithmetic, this should get you to 5/8. So my equation is y plus 1/2, 5/8, x minus 1, oops, not x. We need delta x, which is 1/4. And solve for y. And we can just leave your answer like this. If you simplify it, it is negative 11 over 32. Okay. Last part is asking us to solve this differential equation. And we're going to do it by separating variables. That is the only way we know how to solve a differential equation, to separate the variables. So that means there's my differential. We have to divide by the y squared and then move the x's over here. And then go ahead and take the antiderivative. So remember, this is really y to the negative 2. If we have powers other than 1 on the bottom, we want to bring it to the top. So if I add 1, divide by the power, and then this, just do each piece separately, x squared plus 2x plus c. Let's clean this side up. So it's negative 1 over y. And we have to solve this for y. There's lots of ways you can do it. I just cross multiply, and if you do that, this is what happens. So this is my equation for y. This is the point you're going to use to find c. So plug in your x and your y. So c has to be 1. So this is my particular solution.